It's a lot of fun working for General Electric. You've got all these different verticals that we serve in research. A lot bigger things than cars typically, although we do light bulbs, but mostly thinking about gas turbines and locomotives and aircraft engines and things like that. So when you think about those kinds of analytics, there's a tremendous amount of physics and that physics-based knowledge that needs to come into the analytics. Cars and car engines are very physics-based machines, and I think that there's going to be a need in a lot of things to integrate at scale physics and analytics. Maybe I should say, what are a lot of the startup companies leveraging? It's a tremendous amount of data-driven analytics. The end of authoring software by humans is kind of coming to an end, because machine learning is software writing itself, and it's designing its own solutions from the data, and now, with having this human in the loop, but how does the human get out of the loop? Well, you've probably heard a lot about deep learning. This is a pretty exciting area. It's taking off like crazy, but there's some issues with it. Now, so what is deep learning? Deep learning, in some sense, removes that human between the data and the machine learning. So it's a mathematical construct, neural networks, where the mathematics happen to be very similar to how our neurons fire in the brain, and some really crazy things are going on. They are able to train these deep learning networks to, say, recognize objects in imagery. But even more interesting than that, when they do this mathematical training of these deep learning networks, and then when they do biological experiments, like say give a monkey a craniotomy, and they're able to see how the monkey's neurons are firing, they can take the sensor readings from the monkey's brain, and they can tell what the monkey's looking at. Because the way that this mathematical construct recognizes things in imagery is very similar to how that's happening in our own brain biology. This deep learning is making significant advances in speech recognition, in image recognition, in areas like that. But it's not everything. So where's the value case in all this? Well, there's also massive amounts of value. We saw that in the consumer internet, with Amazon and Google and those great companies. There is a tremendous amount of value there, so there was a tremendous amount of investment in the analytics. The same thing is true on the industrial side. So what that means is there's a tremendous amount of investment for these product companies to keep these large assets operating at peak operations. Now, what did that used to be 10, 15, 20 years ago? It was people, it was engineers that would be on site, measuring, monitoring, listening, and that has dramatically changed over the last 10, 5, and now rapidly within the last few years to be almost 100% of an analytics game. These things are 100% wired up with sensors. To Joe's point, you got to care about the environment, the data. IBM bought weather. You got to care about the environment they're operated in, the maintenance schedule of these things. You got to take all of that data into play, and all of your domain knowledge, all of that background knowledge, and you've got to not only have alerts to see if something's going wrong, but you want to run optimization analytics so that they can operate the asset so something never does go wrong. This auto industry has got to be top of class in integrating design and manufacturing. So there's this evolution, maybe it's moving so fast, it's a revolution in analytics, where people are not creating bespoke analytics anymore. They're not getting the data together, getting an algorithm together, people, to deploy the analytic. That's pretty much gone. It's not just all about the same anymore. It's not about, okay, we got a whole bunch of cars out there, let's get all the information from the cars so that we can have the same rules and guidance for all the cars. It's getting very personalized. Now everything's at scale. It's scale because of big data, but it's also scale because we're able to integrate physics. It's a lot of taking the domain expert and having the analytics automatically generated and getting the domain expert in the loop so that they're making the decisions better and better and better, but you're also capturing all that knowledge at the same time. and it gets this escape velocity to automation. So a lot of the analytics are not just a static analytic development anymore. It's getting the domain experts in the loop in a system so that the system gets smarter and smarter and smarter. And it's all about physical plus digital. Where does all this seem to be going to get it at scale? If we want to think about cars, it's about taking all of that sensor data, and it's about having an individual model of every single individualized asset running. You could think about it in the cloud, running on each individual asset, continuously updating the parameters of that car. So you have all your physics-based knowledge being updated and those physics-based parameters being estimated. And then on the backside of those physics-based models, mechanical, thermodynamic, that are looking for life of the parts, performance, etc. Then on the backside of that, you'll have you could think of it an API or whatever you want, where then a whole different group of people are going to be developing applications where there's going to be a tremendous amount of innovation. In general, you just got to think about it. There's the data that's very important, that's going into these personalized models that are loaded with physics and domain knowledge, and then there's going to be some kind of an open interface for the world to develop applications. So what's the power of this? Well, when you have things when you've got the world in a digitally modeled in a way that matters and it's continuously updated, well, now think of scenario planning. Now you could have analytics that allow you that move into the future. But if you can do scenario planning and start probing different ways that the future is going to be, well, now you can put that into massive compute and start to do optimization. So now you can start optimizing your assets. And it's gonna go there in one step, and now you're gonna start to see that all of the intelligence is being collected in the data of my asset, which is up in the cloud, and how do I monetize that?